Okay. So first, thank you guys for joining us in this last talk, I think so, at PasswordsCon. I just have to say that I'm fucking tired. I just arrived from Brazil. And I hope you enjoy. And if you have any questions, just let us know during the call. Just raise your hand or just speak up. And we are trying to answer. So an agenda, just who we are, introduction to Secure Desktop, what is it, what it works, Windows API, our proof of concept, mitigation, and some conclusions. Who here knows, I know some guys here know, what is Secure Desktop? No, you, I know one of you. And you, what is Secure Desktop?
To make sure only the user is answering the question, but they don't get paid.
Yeah, basically like that. So, just to let you know, this name, Secure Desktop, is not created by Microsoft or something like that. It's just it's a practice that some developers, I don't know who, developed just to protect the application from the other's process in the desktop. So they call it Secure Desktop, and some applications utilize it to protect some passwords in this case. And we did something just to capture these passwords, and this is what's going on here. So a little bit about us. My name is Bruno Gonçalves de Oliveira. I'm a senior security consultant at Spider Labs, TrustWave. I'm a MSc candidate, just working with offensive security in the past. I gave talks at PPSec USA, ThoughtCon, Source Boston, Black Hat, Source, Barcelona, DEF CON, Hack in the Box, TurkCon, etc. And then we have Marcio.
Hi guys, nice to meet you. My name is Marcio Almeida. I'm a security consultant in TrustWave Spider Labs. I'm doing most of my time application penetration tests and application things. I have a master degree in Federal University of Pernambuco. It's a city of Brazil, and I give talks in Alligator Security Conference. And you shot the sheriff.
So let's start. So what is it, Secure Desktop? As we just discussed it, Secure Desktop is not created by Microsoft or anything like that. It's just some practice or a way to protect the application against other process. So in this case, the other process are malicious. So we are thinking about keystroke sniffers. So when you install an application like 1Password or KeePass in your desktop, in your workstation, you're trying to protect your passwords, right? And how you protect your password? With a master password. If you get this master password, what happens? So you just lose all your concept about security and everything. And in this case, these both vendors utilize the Secure Desktop to protect against keystroke sniffers utilizing the Secure Desktop. So basically, it's a new desktop created from the original one. So utilizing the Windows API, you can just manage the desktops in your workstation, your desktop. So you can create a new desktop. You can delete this desktop. You can count how many desktops you have, etc. In the end, only accessed with system privilege. So even if you have users level privilege in your desktop, you're not able to create a new desktop if you don't have this privilege, like system privilege. So here is just a note from KeePass, and you can see enter master key on secure desktop. In the end, I will explain a little bit more. As you can see, I'm just talking about userland process and privilege, because when you're working with kernel land, you're not talking about the application, but you're talking about the operating system. So that's not the point here. Most of you can talk, hey, but I can sniff your keystrokes utilizing a kernel land sniffer, right? But it's not up to us. It's not what we are trying to do here. We are trying to fix the application, not the operating system. So it's all me. Okay. So how does it work? So in Windows API, we have these functions from desktop objects, and there's the library that you can utilize to create a desktop, enumerate the desktops, and everything that you have in your workstation. And again, it's only accessed with system privilege. I have here a little demo just to demonstrate how the security desktop works, and just to illustrate for those that don't know or want to know. It's right here. I don't remember how recording, so let's watch and pay attention because I really don't know. Okay, so here I'm creating a session utilizing the meterpreter. Just to, I'm going to utilize the key scan start feature from the meterpreter and test the security desktop. So I'm utilizing key pass here and enter the master password. So as you can see, I typed the master password, but I couldn't retrieve. And this is how it works. So it generates a new process and a new desktop, and my default key scan dump, for example, the key scan sniffer can't retrieve what I typed. So this is just to illustrate how the security desktop works. Okay. So while I was thinking about, because I have to tell you a story. This idea came from because we had to work with an application that utilized the security desktop functionality in this application. So we were trying to do stuff on this application, and then we thought, hey, let's try to inject a payload in the process and try to see what happens, because to me, we were not clear about the security desktop and desktops and how it manages. So that's what we tried. And is it here?
Yeah.
So in this case, I did the same thing, and then I opened the key pass. Take a look on the process, and I'm going to inject another payload in the process. Successfully injected. And then I'm going to utilize the key log sniffer, just to make sure that is in the same process. And even so, I couldn't get any return or any results from there. So that made us think a little bit more and made some research to learn how it works. And then was what gave us some ideas. So what I was trying, I was thinking about, hey, this application we have to see, we have to monitor, we can. This is our goal in this project. We have to monitor the screen or capture the screen or anything like that. And I could capture the screen utilizing the metaprep payload, and then we try this. We utilized the VNC.
Just an addition. In this case, using the VNC payload with a courtesy shell. It's when the VNC payload triggers in the machine, they just call for our CMD and open it. And when the CMD open it into the secure desktop.
So as you can see, this shell is being executed in the same desktop that the master key request is running. So I don't think, okay. So here what I did, I try, hey, let's execute our payload from there and see what happens. I really like Metasploit's very fast, right?
It's a good tool. It's a good.
Well, now as you can see, I executed the payload in the same desktop that the master key is running, the key pass is running, and then okay, I captured successfully the password from the master password from the key pass. So from there, we just learned that any process that can interact with this new desktop created by the master password, the key pass. So if we can interact with those with this desktop, we can compromise it. So from there, go on.
So okay. So when we see this behavior in the security desktop, when the payload runs inside the security desktop, and we able to capture what's typed, we think, what's happening here? Why the other desktop we isn't able to capture anything, but when it runs the payload inside the security desktop, we're able. So we researched some programs and some examples in the internet, and we found the desktop API and how it works, and all functions used by the program to create, or to close, or to switch desktop. So here, all functions used to manipulate the desktop. Okay, the first one, when you calls him, it closes the desktop. The second one creates one. The third one return array of strings with all names of the desktops running the session. Get red desktop, return the active desktop. For example, if you have 4 or more desktops in the Windows, the desktop active to you is the threaded desktop. Okay, and the open desktop and the open put desktop give you permissions to run program and process inside him. Set red desktop, you set the actual desktop to commands, and the last one, you switch the desktop. For example, if you decide that the default desktop and will to another desktop, you call switch desktop to switch between them. Okay, so it's the functions. We see how used them, but to explain why the when you call the process inside the security desktop works is because of that. In the Windows API, the session has inside him 1 or more Windows stations. Inside of Windows Station, you have 1 or more desktops, okay? And inside the desktop, you have programs, process, user input, everything shared between. So because that, when you run a program or a process inside the same desktop, you're able to capture everything. Okay, so why no that doesn't work when you call a secure desktop? Because this desktop isolation. Because when you run a program inside the default desktop, when you interact directly for a secure desktop, you are unable. But has one thing: since you are inside the same Windows station, you are able to send commands and send start process inside the other desktop, not interact with him. So we're thinking, okay, so let's create a proof of concept when we not interact directly for another process. We just run a keylogger inside the other desktop and see what happens. So this was our proof of concept. Our program is just using the secure desktop API. We just run another program inside the secure desktop, and the other program will do what they need to do to capture everything, because they will bypass the security protection from the other desktop. But when the program is running the same desktop, the protection isn't as anymore. So is a proof of concept what we developed. First of all, we run an open desktop to open them. The other desktop what we want to interact. After that, we set the threaded desktop to this desktop. After that, we create a process. In this case, a malicious process. Okay, a keylogger. In this case, we used a steel keylogger. It's a public keylogger, public in internet that interacts in userland. So here is the code. Sorry for that, it's very lame, but we are not coders, just pen testers. We create a while true and get the names of all the stops, and when we found one new, just launch a new process. So for example, we're running the default desktop. Your program starts a keylog in the default desktop. Okay, so when you start the KeyPass or password or any program that uses secure desktop, we inject a new payload to start our malicious process. In this case, we will just call a CMD. Let's show here. Okay, we will show to you two programs. The first one, just called the CMD, okay? We start here. When you launch, they will get all desktops, names, and start to CMD. Okay, just did it. Now we will start a program vulnerable to attack a KeyPass, just running. Okay. Come on, open. Okay, open it. So, Alt-Tab. Can you see? We have the CMD opened inside the security desktop and the master key. So in theory, if we have a keylogger running inside the security desktop in that moment, the user never know that and have his password captured. Okay. Now we'll show to you running with our keylogger to capture. Okay. Okay. The process, we'll close this one and start the other. This one, when we start, they will start a keylogger in every desktop in the machine, and when I start a new desktop, they will inject a keylogger inside this desktop too. Just running. Okay, let's see task manager. desktop injector is running here, and they just injected the 1.az. This one is a keylogger running in the default desktop. Okay, so I will run the key pass again, and here I will type my password. Password type secure desktop. Okay, so what I typed here will appear in my log archive. Just okay. Okay, the password is incorrect. No matters. Let's see the log. Archive here. Every numbers that appears here in Task Manager is a keylogger process running in every desktops in the machine. Let's see here in the log. And let's just wait. Okay. Type it on secure desktop. Okay. Just wait a little bit more. Because this keylogger just archive the logs during 30 seconds or every minute. Here, new one. Everything I typed, the desktop is logged. So, is our proof of concept. What we did by mitigation this? We have just a recommendation, okay, based in session isolation. Because if you create a new session and on this session you start a new desktop and everything you want, you have a totally isolation. It doesn't matter if you can try or interact with the desktop, you are unable to do that. And
We didn't test it.
yeah, we don't totally tested, just a recommendation, okay? But since we are pen testers, we know that hijacking sessions is possible, okay? So we not tried totally if we hijack a session and trying to everything to do that. We don't finally test. We need more research, but we really think that we'll solve the problem. And we have another solution created by 1Password addressed in DCVA, where his solution is very, very interesting. He just, when you launch the 1Password, they detect if it has another process or program running the secure desktop, and when they detect this problem, it just close the desktop and alert the user, hey, has another process or program running inside your secure desktop, so take care. So this solve our attack and solve the problem. And our conclusions is basically the secure desktop is a very good feature. Okay, they really protect your password if you implemented it in the correct way. Because if you just implement and give it away, like we demonstrated in this talk, you are able to have your password captured and then you hack it. Any other consideration?
Yeah. As I told you before, just to make sure that we are in the same page, we're just talking about user land, and we are not talking about operating systems. So since you have a driver installed in your operating system, what you can do?
You're a hacker anyway.
Bad luck. So we're just talking about application. That's what we have some great response, not just because they're sponsoring here, but we have a great response from 1Password. They're great. They gave us free software and responded very fast. So they really like it, and that's because. As you can see, it's because nowadays actually that Microsoft demands signed driver and everything. It's a little bit harder to get it, but as you can see in the application level, we're done. So that's it, guys. Any questions?
Thank you very much for
Thank
watching
you.
us.